Hi everybody, this video is going to talk about something called direct variations. Now, a direct variation is a specific relationship where we have this constant ratio between all of the ordered pairs. And that constant ratio is going to be given by the variable k. Another word that you might hear is the constant of variation. And whenever you hear constant of variation, we're talking about this variable k, which is really just representing this constant ratio between all the x and the y values. Now, if we can identify a relationship or a relation, a function as a direct variation, the equation is very simple. The equation for a direct variation is just y equals whatever k is times x. And I want you to see the similarity here between our slope-intercept form that we've been working with and this direct variation form. Now, we're missing the plus b part. And if we're missing it, then that means that it's really a zero. So what you can get from this is that direct variations always have y-intercepts of 0. Okay, and since it's always 0, there's no need to put the plus b because plus 0 is, well, it's not necessary. So that's one connection, similarity. You'll also notice that instead of m, we're using k. And we use k because we're calling it the constant of variation. There's a special way we can find it, but graphically speaking, k is really still going to represent the slope, right, or the rate of change. So let's look at how we can find this k value, this constant of variation, and then use it to write an equation for that relationship. So in all these problems here, we're assuming that these are direct variations. Like, we start off knowing that. Our job is to identify the constant of variation and then use that to write an equation for that relationship. So if I want to find k, I'm just going to pick one of these ordered pairs, and I'm going to do y divided by x. So let's pick this one. It doesn't matter which one I choose. I should get the same k value regardless. So if I use 312, I'm going to take my y value, divide it by my x value, and simplify. So here I get k is equal to 4. Well, if k is equal to 4, and my equation is y equals kx, my equation for this is y equals 4x. And we can check. If I take the x value from each of these ordered pairs and multiply it by 4, it should give me the y value. So if we look at our first one, okay, 4 times 1 gives me a y value of 4. 4 times 2 gives me that y value of 8. 4 times 3 gives me that y value of 12. 4 times 4 gives me that y value of 16. Okay, so it's really just a nice way to help you figure out what is the equation for this relationship. So let's jump down and look at one of these ones with the table. Okay, remember, we can pick any point. Now, I want to kind of bring attention to this one right here. One of the points is 0, 0, and there's nothing wrong with that, but for finding our constant of variation, this isn't a very helpful point, because if I do my y divided by my x, well, it's undefined, and that's not helpful at all. So avoid picking points that have zeros. Whatever relationship we end up still going to work with that point, it's just not a helpful point for finding what k is. So let's pick our first one, -12, -8. So k is equal to the y value divided by the x value. So if I have two negatives dividing, I know it's going to become a positive. So let's go ahead and just write that as positive 8 over 12. And then both of these are divisible by 4. So we can reduce this to 2/3. So I found that k is equal to 2/3. So my equation is y equals 2/3 x. And let's do number 4 as well. Let's pick any point here. Okay, let's pick 3, -9. So if I do k equals y over x, we get -3. And if k is negative 3, then my equation is y equals negative 3x. And remember, this is just the equation that's representing the pattern that's found in this relationship. Now, maybe instead of being given a set of ordered pairs or an equation, or I'm sorry, a table, we're given an equation instead. So we want to be able to look at equations and determine if they represent a direct variation. Now, remember, direct variations are written as y equals kx and have y-intercepts of 0. So for number 5, our y-intercept is 0 because it's not written, which means there's really a plus 0 here. And it matches our form, okay? In this case, y equals 3x is a direct variation with a constant of variation of 3. 6 is also a direct variation with a constant of variation of negative 4/5. Okay, and I can tell because each of these have a y-intercept of 0, and I can easily identify what that k value is. Now, number 7 is a little trickier. I'm not missing my y-intercept. What I'm missing here is my slope. So I really have a slope of 0, which means I have 0x plus 2. And if I have 0x plus 2, it's easy to see that I do not have a y-intercept of 0. I have a y-intercept of 2. So this is the first one that is not a direct variation. Let's look at a few more. Okay, for number 8, something that we haven't had to talk about yet is what happens if there's a number in front of a y? What if this isn't in that y equals kx form? Okay, well, that's fine. We can really easily get it there by just solving for y. All we would have to do is divide each side by 2, and we get y equals 5/2 x. And now we can see that this is an equation with a y-intercept of 0, a k value of 5/2. So we can say, yeah, this is a direct variation, and our constant of variation is 5/2, or 5/2. Okay, number 9. Number 9, we can see the y-intercept here is negative 4. It's not 0, so this one is not a direct variation. Number 10, we have a y-intercept of 0, and the number in front of x is negative 1, so we're going to say, yes, this is a direct variation, and our constant of variation is negative 1. Now, let's look at how we can look at a graph and determine if that is a direct variation. Now, it comes down to remembering a direct variation has a y-intercept of 0. So if we have a graph with a y-intercept of 0, we're going to say yes. And if we have one with a y-intercept of something else, for the ones that we say yes to, we want to write the equation, and it's really simple. For a direct variation, we know it's y equals kx, and we said k is, well, it's really going to be the slope. Okay, so if I find the slope of this line, rise over run, 3/2, I can say, yes, this is a direct variation, and more specifically, this is y equals 3/2 x. So let's look at a few more here. So number 16. We have a y-intercept of 0, so we know it's a direct variation, and to write the equation I need to find the slope. So in this case I have to go down 1, right 4, so my slope is negative 1/4, meaning my equation is negative 1/4 x. All right, last one here. So yes, it's a direct variation because the y-intercept is at 0. To find the equation, I need to know my slope. So here we have to go up 3, right 3. Okay, but if we think about it, 3/3, if I have k equals 3/3, that's really just 1. So our equation is y equals 1x, or really just x. Now, the last thing that we're going to look at with direct variations is how we can use them to solve for missing values. So in each of these examples that we're going to look at, we know that we're working with a direct variation. and we're trying to find this missing value. So for 18, we know that 2, -4 is a point on our direct variation, and -6 something is also a point in this direct variation. We need to know what that something is. So what we're going to always do is start with the point that we know everything about. Okay, we know the x, we know the y. This point will tell us the k value, or the constant of variation, of my direct variation. Okay, this tells me the constant of variation is -2, which means the equation for my direct variation is y equals -2x. So this is important because this is the same pattern that should apply to the second point. Okay? If I know y equals -2 times x, and I know x is -6, and I'm looking for y, all I'm doing is plugging in -6 for the x in my equation and solving for y. In this case, y would be equal to 12. Okay, let's look at one last example here. In this case, I'm solving for a missing value of x, but before we get there, we're going to start with the point that we know. We're going to take y divided by x, so 16 divided by 4. Our constant of variation is 4, which means our equation is y equals 4x. Now here's where we have to be careful. We're solving for x this time. We don't know what x is, but we know that y is 24. So instead of plugging a number in for x, we're going to plug in 24 for y. We're going to say 24 is equal to 4 times whatever this x value is. And we solve for x by dividing each side by 4, and we find that x is equal to 6. So to wrap it up, direct variations are really just a special kind of linear relationship with a y-intercept of 0, and k is really kind of serving as our slope here. So feel free to rewatch, rewind, ask questions, and I hope you have a great day.